Hello, how are you? Welcome to today's structural engineering class. I hope you're all doing great and I hope your week has been awesome. Today we are going to study about the process, the structural design process. In structural engineering, civil engineers or rather structural engineers, they're normally the ones who carry out the design of the structural members of the structure. They carry out the supervision of the construction, and they can also sometimes provide consultancy services in bigger projects by designing, detailing and supervising the subsequent works on site. Therefore, today, if you are a young engineer and you want to know the process in the field, welcome to this channel. This is for you. Also, if you are a client or you are just a layman, not working in the engineering field, you could want to build, or you have maybe a site where you have assigned some engineer some work. This is also for you so that you know the process that your engineer is going to go through, so that you avoid shortcuts, because an engineer can decide to use shortcuts because a layman does not understand this, and that is not ethical in the field. Therefore, welcome as we study together. Please subscribe to the channel and press the bell icon for any notifications, because we release these educational videos from time to time. So, what is the first process of structural design, or which process does a structural designer go through? First of all, in construction, drawings or the idea of the structure is provided by an architect. After the architect has already designed and drawn the structure and it has been approved by the client, the engineer goes ahead to carry out the design. So the first step is getting the architectural drawing. An architectural drawing is simply drawn so as to serve the purpose that it's required, so that the structure is able to meet its utility. For instance, if it is a classroom carrying 70 students, the architect spaces the classrooms in such a way that the 70 students can fit in that class. If it is a market where we have small stalls, the architect subdivides them like that and loads them in a preliminary design, so that he is able to know how to size his members in the architectural drawing. But in this world, civil engineers, wherever they are at school, they go through a process and they actually understand how to do architectural drawings. So your engineer could be able to produce architectural drawings, though it is advisable you use a qualified architect, and probably an engineer can give a thought or two to help the architect in his design here and there. And that is why in most cases, engineers and architects work together so that they achieve the required utility of the structure and it be a stable structure. Therefore, after obtaining the architectural drawings, be it from the architect or the engineer, the first thing a structural engineer is supposed to focus on are the grid lines. Sometimes an architect can place for you grid lines on the drawing, sometimes they might not, but you're supposed to have grid lines where you have your structural members. These grid lines are called, I normally use to label structural members. For instance, if a column crosses grid C and 1, we can call that column at location C1. So it easily helps us identify the location of these members. Therefore, the structural members include walls, columns, beams, slabs, and such. And grid lines are normally at or along the walls, along the grid lines, and they normally cross columns and etc. Therefore, this is the first thing that as a designer you are supposed to look at. After you obtain your architectural drawings, you proceed to determine the type of structure. We have very many types of structure, and depending on the utility and economy, we might prefer one structure over another. So, type of structure, we have concrete structures, and whenever we reinforce them with steel, we call them reinforced concrete structures. We have timber structures, we have steel structures, and we could be having composite. Composite structures. These could be a combination of both timber and concrete, and or steel and concrete, and many components that we could mix together so that we can obtain the structural integrity of the member we're looking for. And in the type of structure, we also determine whether our structure is braced or unbraced. To understand the ways in which we can brace a structure, please subscribe to this channel and check out our videos. We have a video where we are talking about areas in which we can brace a structure. And unbraced structures are those ones which are not meant to resist any lateral loadings, and we could have unbraced structures or braced structures depending on the utility of the structure. And that comes whenever we determine the type of structure, because this is going to govern us in the design of our structure. The third thing that we are going to do is something we call preliminary sizing of the members. Preliminary sizing of members is where we determine the sizes of our members. If it is a timber structure, let's say it is maybe a circular column, we determine the diameter of the timber from past experience and general knowledge on which size of the structure can support which loadings. Therefore, on looking at your structure, and maybe it's a reinforced concrete structure, we could quickly do some quick checks to do the preliminary sizing of the members, or we could just size, because if we carry out the design and it fails, we come back to the preliminary design sizing to change the size of the members to that which can fit our loadings. Therefore, whenever we do preliminary sizing of members, we might size our columns, we might size our beams, walls, slabs, etc. And for instance, in the preliminary design of beams and slabs, we could check something called the L over D, the span. This is the effective depth, the span over the effective depth of our structure, so that if it is within the allowable limits, we could pick that size as we do the design. And if it fails, then we come back and change the size of our member. Also, we could use the cover of our member, because if we are looking at, for instance, a fire resistance of 1.5 hours, we could provide a cover of, let's say, 30 millimeters to our beam or column or slab. And in the design of a resistance of an RC element to fire, we normally can use the British standards, Euro code, or any other code. And we have also done a video on the same, so you could check in our videos we have talked about designing for cover and structure. So these can also guide us when we add to whatever is here. When we add to the, let's say we are designing a beam, when we get the effective depth, let's say our effective depth was 144 millimeters, and cover on both sides is of 30, that is 60. Therefore, we need 204 millimeters of our element, assuming this was a beam. Therefore, we will have something greater than this in our beam, let's say 300 millimeter deep beam. And we can start with that as we carry out the design. We can try to 50, if it fails, then we can make 300. So this is the second, the third step. And here you just choose your members, and because you are going to use them in your design. The fourth thing is loading in a structure, and we have different loads on a structure. We have dead loads. Dead loads are those permanent fixtures and fittings, including the permanent weight of your structural elements. And we could be having live loads. Live loads are those that are movable, including people, chairs, and cabinetry, and such. We could also be having snow loads in areas where people experience snow, and notional loading in structures, and this affects high-rise structures. And in loading, we normally use something called load cases. For instance, in the British standard, when we are designing for ultimate limit state, we could use 1.4 multiplied by the dead load plus 1.6 multiplied by the live load. And whenever we're using zero code, states to the ultimate limit state, this is 1.35 dead load plus 1.5 live load. And we have many other load cases depending on the loadings. And loadings, we said they could be live load, dead load, we could be having wind load, so in higher structures, seismic loading, in areas with seismic loads of higher magnitudes. We could also be having snow loads, etc. Therefore, these ones are the ones we combine here to obtain the most honorous case, and that is what we will use in our design. And this is not the only load cases to be used. Sometimes students use this only. In high-rise structures, we could be having a higher effect of wind or seismic analysis. Therefore, what do we do about that? We find out the worst case scenario. For instance, whenever we have a wind load, it might cause an uplift of your columns. Therefore, if we use this, we are going to design columns which we have not factored that uplift. Therefore, we need to combine all of them and find out the worst load case scenario. After loading, we go to the next step, which is analysis of forces and moments. In analysis of forces and moments, we can do that manually, or we can use softwares. They do the same thing. And here we obtain bending moment diagrams, shear force diagrams that we actually use in our design. And in analysis, we could be finding the greatest shear forces. We could also be having moments. And in cases like in restrained beams and slabs, we could be having lateral torsion of backing. Therefore, we could be having issues to do with torsion. That one we can obtain also in the analysis. Therefore, whenever we have analyzed our members, is when now we get into the design process. In the design is where we choose the area of steel. have majorly factored the use of reinforced concrete because it's the one that we commonly use in design. Because now area of steel is in reinforced concrete structures, but the same procedure applies to the use of the other members in construction as well. Because whenever you're designing, let's say in timber, whenever you're designing a timber structure, you need to find the actual size of the timber you need and whether you need to brace that timber, and the whole process actually works. In the area of steel, we pick steel sizes and numbers, and we actually check whether this steel and number is able to support the actual load and the total load combination that we obtained there. If it is sufficient, then it is okay. If it is not sufficient, we pick either more steel by increasing the number or increasing the size of steel. And for instance, in my country, Kenya, we have from T8 to 10, 12 to 16, 20, 25, 32, 40, and so on. But the rest can be customized depending on your structure. But from size 32 onwards, it is normally not really available and it has to be customized for you from the manufacturers. Therefore, this is the step where we pick the area of steel. We also carry out the necessary checks. Whenever we carry out the necessary checks, we determine whether our member is able it's not able to succumb to, let's say, cracking. The deflection is not much, it is within the allowable limits. And here, that is where I advised that we use L/D whenever we are preliminary sizing our beams and slabs. Because when you pick something that fails here, then whenever you're carrying out this check, it is also going to fail. So we carry out the necessary checks. We can carry out checks against deflection, cracking, let's say maybe punching shear. Whenever we are doing pad footings or mat footings, or maybe a column could punching through a foundation. So here we carry out those checks, and if the member passes, then we recommend the use of that steel. Number 7 is where we do the detailing of our members. And in detailing, we produce working drawings. These drawings are the ones which are normally taken to the local authorities for approval, and we also take them to the site for construction of the works. And mostly in structures which are not so big and they do not have a lot of scrutiny from the government, engineers tend to leave it at the working drawing phase. Actually, this is normally wrong. And as an engineer, you're supposed to do the last step, which is called supervision, or we can say consultancy on site. Whenever you are doing this process, after generating the drawings and they have been taken to site, you need to check what is the contractor doing. And this will help you so that they do not use shortcuts in construction and they follow instructions as advised. Sometimes they could use the right members, but whenever they are casting these systems, they use the wrong or they do not support their formwork well. Therefore, your elements are going to fail even before they gain structural strength, which is 28 days for concrete. Therefore, you are supposed to provide supervision of your works, and if you're a client and you have an engineer, please involve them in the consulting phase, because here is where we have a problem. Some contractors might be cheeky and they try to use subsequent materials. And at this phase, if they're supervised by a registered engineer, he has to keep them on toes to do the right thing. Therefore, supervision is it's one of the most important processes in this process. But people normally do not take it serious as it deserves. Therefore, in the following of these processes, you are going to enjoy as you carry out your design, and we will study together from the first process to the last process. And where we're going to spend a lot of time is in the analysis and design bit of our members. But remember, in the design and analysis, we use internationally or locally acceptable codes or local annexes that have been accepted by our governments and authorities around here. Therefore, please have them. We need to use, for instance, if you are in America, you need to use the American code, and we have codes for literally everything, be it structural, seismic design, be it timber design, reinforced concrete design, and such. You could also use the British standard or the Eurocode, or like in South Africa we have SABS, which is a local annex used in the design of structural members. Therefore, please ensure you use the right codes and look at your local annexes, something within the acceptable limits. That is what you're going to apply. Please follow the process. Some people might take shortcuts, but it is required that you follow the process. Thank you very much, and I hope you have enjoyed this lesson. I would like to request you to subscribe to our channel and press the bell icon for notifications in the future. You could comment in the comment section if you want us to tackle something that you need to know in structural design. Please bring it up so that we study together. Thank you, and hope I'll see you next time. May the good Lord bless and keep you.